Hey everybody, so this is the follow-up video to the online video we just did for the linear relations test. And this is version 1. There's 2 versions. This version also has the test attached to the assignments tab. Version 2 is the one you'll ask for, and then I'll send it to you, and you'll write the test and send it back to me, okay? So what we're going to do is, step by step, we're going to go through this practice test, and you can follow along. If you have any questions, just text back or chat back through Teams, to point out any mistakes I've made. Okay? Now, in this first part, it's a T-chart, and it says, the pattern in the table continues. Write an equation that relates y to x by following the 3 steps. So we basically want to know, how this one and this one relate to each other. And we always want to write it as a situation where it's like y is equal to something happening to x, and then plus or minus an adjustment. I'll just say adjust, okay? So what do we do first? Well, let's just follow these steps. How much does the dependent variable change by? So this one goes from 4 to 5 to 6 to 7. So each time it's changing by add 1 or positive 1. Now we remember that this is our multiplier. That's our multiplier. So the simple rule is times by 1. Test our simple rule. Okay, so if I go 1 times 1, I get 1, but I'm supposed to get 4. So that leads us to this next question is, what adjustment needs to be made? Well, if I've got a 1 and I need 4, I'm going to have to add 3. So what's our new rule? So remember, our rule always wants to be something happening to x with an adjustment. So here we've got 1 times x plus 3. Whoops, my 3 isn't that good. So 1x plus 3. So finish the equation. Y, well, it's real easy. Y is equal to 1x plus 3. Okay, now the next part says, now use 20 for x and calculate the value of y. Well, what does that mean? So we're going to take this 20, and we're going to put it in for that x, and then just do the math. So y is equal to 1 times 20 plus 3. Well, 1 times 20 is 20 plus 3 is 23. And we're done. Well, that's not so bad. So on the test, it's going to show you a chart like that and just take it through some simple steps. If you follow the steps, you can't go wrong. Okay, now here it says complete the table. All right, so if we just look at this part here, from 4 to 7 is, I'm going up by plus 3. And guess what? It's the same. So if it follows that pattern, this next one will be 13, and the last one will be 16. But the question says the independent variable and the dependent variable. Well, what does that mean? Well, here I've got J and K. Which one is independent and which one is dependent? Well, you can think of it this way. The reason why the 4 and the 7 and the 10 and the 13 and the 16 changed was because we were at different J's. So K depends on what number J is at. So if we're talking dependent, well, that's this guy. So the dependent variable is K, and it's always If you can think of it as x, y, it's always on the y side. And so this one would be j, the independent variable. Okay, now, that question stops there. Number 3 is a whole new question, all right? It says, given the line y is equal to negative 6x plus 3, the slope is, all right? Now, when they say slope, they mean that multiplier. That's what slope is. So up here, our multiplier was plus 1. That's its slope. Here, the change was plus 3. So that's our multiplier. Here, this says negative 6. And it's okay if it's a negative. Mom said it was okay. So that's negative 6. And the y-intercept. Well, the y-intercept is right there. Plus 3. That's where it cuts through the y-axis. So in this one up here, when we're doing this adjustment, if we were going to graph that line, we would throw it through the y-axis at plus 3. So our y-intercept is plus 3. Now we want to sketch the graph. Now remember, slope is 2 words, rise over run. Well, here, this negative 6 means I'm going to go down 6. And then I'm going to go over 1. So instead of rise, because of the negative, it means going down. But down from where? So the first part that we have to do is look at our y-intercept. So we're going to look at this guy first. Plus 3. So there's my y-axis, and I see 1, 2, 3. So I'm going to put a dot right there. So my line has to go through that black dot. Okay, but how does it go through? Does it go straight up, straight down, whatever? No, it goes by the way of this. It's going to go down 6 from there and then over 1. Okay, so if I do that, I'm going to go 1, 2, 3, 4, 5, 6, and then over 1. Right there. And guess what? That's my slope. I went down 6 and over 1 from that initial spot. All I got to do now is open up a line and put it right through. Oh, here, let's make that a little bit better. There. And bring the side over. Boom. Okay. So that's essentially it. So this whole unit has been about being able to look for a change. Whoops. Move that around there. Being able to make an equation from a t-chart. Okay. Then to write it in the form of an equation and then graph it. And that's what we've got. So when we said y is equal to negative 6x plus 3, well, we don't even need a t-chart of values to graph that. We just have to start here first. Start there first. And then go from there. And Bob's your uncle works out great. Okay, let's look at the second page. Okay, now here it says, what is the equation of this line? Now, I'm just going to throw in another line on top of that one so it's a little easier to see. There, hopefully that's better for you guys. Okay? Good. Now, what do we want to do? Number 1 is we want to go to our y-intercept. Our y-intercept, okay? Now, what is that? That means where does it cut through my y-axis? Boom, right there. So my y-intercept is negative 2. Okay. Well, what do I do next? Well, next, I want to find my slope. So I want to find slope from my y-intercept. Now, what does that mean? Well, that means I want to find where it crosses through the next intersection. Well, the next intersection is basically where it crosses right through the streets, I guess, so, and not partway in between. So, for example, if I highlight here, watch what I'm going to do in green. Like, this is no good because it's not really anywhere. Like, it's not really at +1 or 0. And as we start to move off the line, that's no good, and this is no good. The reason why the red ones are good is because they have a definite intersection. Okay? Right. So, now, if I want to go from my y-intercept right there to where that +4 is, I've gone up 1, 2, 3, 4, 5, 6. And then I'm going to go over 1, 2. So I went up 6, so I'll go +6, and I went over 2. Oh! So all I'm going to do now is I'm going to take this, and I'm going to take it with this, put them together. So I'm going to go y is equal to 6 over 2. Whoops. 6 over 2 x minus 2. Now, for the math kids in the room, you probably look at that and say, well, but Mr. Chambers, I can simplify that 6 over 2. Yeah, and 6 divided by 2 is 3, so I could even say y is equal to 3x minus 2. And this is my y-intercept at -2. And this was my slope. That's how I moved. Okay, now on the next one, so if that was true, and it is, maybe this one might be even easier. Graph the line y is equal to 1/4 x plus 2. Remember, we start at the y-intercept, +2. So we're going to do this first. +2, 1, 2, right there. So my line has to go through that red dot. But how does it go through? So we say ourselves, how does it go through? We say, what is its slope? And that's this one. Well, that's 1 over 4, which means it goes up 1 and over 4. So from here, I'm going to go up 1 and then over 4. 1, 2, 3, 4. Oh, so I'm just going to put a line right through those 2 spots. There we go. There you go. I just graphed the line. So remember, we start at the y-intercept, and then we do the slope. Now, why is this important, or how does it work? Well, maybe sometimes the best example is one that involves money, because every teenager likes money, right? Like, I'm not lying to you. I like it too, and I'm not a teenager anymore. But a cost equation also follows the same form. Y is equal to something happening to x plus or minus an adjustment, a cost adjustment. Well, let's look at this. It says it costs $2. It costs $2 to use the postal service and 5 cents for each letter mailed. Write a cost equation. Well, it's always something about y. So, in this case, instead of y, what we're going to call it is cost. The cost of using that mail delivery service is 0.05 for each letter. So when it says each letter, that's X, because X stands for how many letters we're going to have. We don't know right now, so that's why we'll just use the variable X. Okay, whoops, trying to make that a decimal. Good. Okay, then what? Well, look at this adjustment. Plus 2. So it's going to be 5 cents a letter plus $2 for going. Okay. Here in letter B, it says, how much does it cost to mail 100 letters? So we just go cost, because it's a cost equation, is equal to 0.05 times 100 letters plus $2 for going. Okay, well, 0.05 times 100 is 5. And plus my $2 for going, my cost is going to be $7. $7 to mail 100 letters. So now this is version number 1 of the test. Version 2 looks a lot like it. So if you've done the work, if you've watched the videos, this will help out. Okay?